Hello, and welcome back to another episode of Maths with Mr. Mitchell. So, in this particular question, we've got the function g of x is x cubed minus x squared minus 12x. Obviously, we should recognize that that's a positive cubic function, and it cuts the x-axis at the points A, B, and C. And we're asked to find the coordinates of A, B, and C, and then we're asked to find the gradient of the function at that point B. Now, this is really interesting because what we should identify is that when any graph cuts the x-axis, any graph cuts the x-axis, obviously that's the x-axis is y equals 0. That means that any of those two roots where it cuts the x-axis, the value of y will always be equal to 0. Now that's really important. The next thing what we can recognize is that, well, how am I going to go about solving and finding the roots of this cubic function? And what's really sneaky in this function of g of x is that we've actually got an x in each of the terms. So let's just take out and factorize. Take out a factor of x. So x outside of x times x squared gives me x cubed. X times minus x gives me minus x squared. And x times minus 12 gives me minus 12x. And now, what can I do there? Well, I can factorize a little bit further because as soon as I get all the possible factors of that cubic function, well, I can then find the roots. So in this quadratic, let's look at finding the sum and product to see if we can find the other two factors. So I need to find two numbers that add to minus 1, but multiply to give minus 12. So that would be minus 4 and positive 3. So these are my other two factors that I can use to factorize this quadratic. So I get equals x outside of x minus 4, x plus 3. And now I have three factors that make up my original cubic function. So what we know is that at any root or solution, y, or the function, cuts the y-axis at 0. So I can say that either x equals 0 or x minus 4 equals 0 or x plus 3 equals 0. So I have one root at x equals 0, the second root, which is x equals 4, or a third root at x equals minus 3. So if I now put them in order, I could say, well, the first solution, A, moving from left to right, would be x equals minus 3. The second solution, B, would be x equals 0. And the third solution, C, would be x equals 4. Rightio. So, first part of the question is done. And then it asks us to find the gradient of the function at point B. So, part 2. We want to find the gradient of the function at point B, and that's when x equals 0. So remember, in our toolkit, we know that the gradient of our function, so the gradient of our function is equal to the derivative function, okay? So let's now first of all find, if we have our original function, which is x cubed minus x squared minus 12x. Let's find the derivative of that first. So we get the derivative of g of x will be equal to 3 times 1 is 3, decrease the power by 1, so 3 minus 1 is 2, minus bring the power down, so 2 times 1 is, 2 times minus 1 is minus 2, x to the power of 1, because I'm decreasing the power by 1, and the derivative of minus 12x is going to be minus 12. So this is my derivative function. So now I want to do is I want to find the gradient when x equals 0. So I'm just going to substitute that into my derivative function. So 3 times 0 squared minus 2 times 0 minus 12 gives me minus 12. So that means if I look at my actual original function, I've got the graph sketched over here. If we look at the original function of my cubic, we can see that we have one solution here at x equals minus 3, the next solution at x equals 0, and the third solution, C, at x equals 4. And at this point, when x equals 0, we can see that the derivative is in fact minus 12, or the value of the derivative is minus 12. Okay, hopefully that helped, and thanks for joining.